Welcome to video 4.1 on general probability. There are a lot of different probability rules that we had talked about as part of our class, but we're going to focus on two main ones of what's most likely to be seen on the AP exam. There are others you need to review as part of your review process. Some of the things that you should remember is the probability of any event is between 0 and 1. You should also know that the probability of all events in a sample space must add up to 1. And remember the complement rule. The complement rule is the probability of the complement is 1 minus the probability of the event. So make sure you're reviewing these on your own time, and we'll hit what you're likely to see. So when we have some problems about probability, the first thing you really need to be asking yourself is about mutually exclusive or independent. You should ask yourself, are these events mutually exclusive? Are these events independent? Okay, so let's start with our mutually exclusive. Okay, so these are OR problems. Mutually exclusive means events cannot occur together. So if we're looking at two things, they cannot occur at the same time. Okay, so if you ask yourself, are these mutually exclusive? And your answer is no. The rule that you're going to use to find the probability. So we're saying the probability of A or B in non-mutually exclusive events is the probability of A plus the probability of B. And because they're not mutually exclusive, you need to subtract the overlap, is what we called this when we were learning about it. Because really what's happened is this group has been counted twice in the probability of A and in the probability of B, because they occur in both places, and so you want to subtract the duplicated off. Okay, so hopefully you're remembering, if we're saying it's A or B, the word or means plus, we're adding. Okay, now what if they are mutually exclusive? They cannot occur at the same time. They cannot occur together. Well, it's just a simplified version of this. If they are mutually exclusive, the probability of A or B is simply the probability of A plus the probability of B. Because they have no mutual exclusiveness, there's nothing in common, there's nothing to subtract off for an overlap. So to put this in kind of some math terms, events that cannot occur together, mutually exclusive, is the probability of A and B equals 0. There's zero chance they're going to occur at the same time. Now, that's mutually exclusive. That's going to be an OR. That's when we're adding. The other thing that comes up is independence. Independence is going to occur with an AND situation. And when you hear the word AND in a problem, you got to think multiplication. Okay, so independent, hopefully you recall, is knowing the outcome of one event does not change the probability of the other event. So what is meant by independence? A deck of cards is kind of your easiest example. Is if I shuffle the cards and I draw a Jack of Hearts and I'm holding it in my hand, that changes what I know about the cards remaining in the deck. That's not independent. However, if I shuffle the cards and I pull the Jack of Hearts and I look at it and I put it back in, that did not change what I know about the deck. Okay, so independence, and how we check for independence. If they're not independent, the probability of A and B will be the probability of A times the probability of B given A has already occurred. Okay, so the probability of A and B would be the same as the probability of A times the probability of B given A has already occurred. That's if they're not independent. If they are independent, knowing the outcome of one event doesn't change the probability of the other event, then the probability of A and B equals the probability of A times the probability of B. They'll be exactly the same number. If they're not independent. Okay, so on our formula sheet we had some defining the independence, but here we have mathematically that the conditional probability would be the same as just the regular probability. Is really your overall idea that you want to take away from this. If they're independent, the conditional probability is the same as the overall probability. All right, now we're going to do an example to kind of help you with this. One of the hardest things on the AP exam is being given a story problem and pulling out the information on it. So let's take a look at this, and we're going to pull out some information and answer some questions. So in our example, Stella's Lounge only sells burgers and sandwiches. Each comes with chips, or for $1 more, it can be served with fries. The probability that a randomly selected customer orders a burger is 60%. If they order a burger, 70% of the time they will get fries. If the customer orders a sandwich, they get fries 45% of the time. What is the probability that a randomly selected customer orders, and then I have 3 questions I want us to ask, a sandwich and fries, fries only, or a sandwich given they order fries? All right, so let's write down what we have here. We have the probability of a burger, which this said was 60%, so I'm going to write it as 0.6. We have the probability of fries given they order a burger, I'm going to use just B for burger, equals 0.7. And then they have the probability of fries given they ordered a sandwich, and that's 0.45. That's what I have from the story problem up here. So when you're going to try to answer these kinds of questions, you want to look at making some sort of model, like a tree diagram or two-way table, to help with this. So that's going to be our first AP tip. So we're given the information, we're going to try and create a model to help us with the situation to make it easier to answer our questions. All right, so let's take a look. At Stella's Lounge, there's only 2 choices. You can only get a burger or a sandwich. The problem tells us that 60% of the people order a burger, so the probability of a burger is 0.6. And automatically that makes the probability of somebody ordering a sandwich 0.4. The problem goes on to say that if the person orders a burger, there's a 70% chance they're going to order fries. So we have our burger people. This is going to go on to say that they get some fries 70% of the time. So 70% of the burger people get fries. That means 30% of them get chips. Right? Now let's look at the sandwich people. It says the probability of getting fries given they have a sandwich is 45%. So they got a sandwich, so the probability of getting fries is 45%, which means the probability of them getting chips with the sandwich is 55%. Remember, each of these splits, every time you do a split, it should equal 1 when you add them together. For each split, because you're saying of these people, you have 100% of these people, what's happening with them? You're dividing them out into what they did. All right, so what we will do here is to find some probabilities is we're going to multiply along the arms. So this line would be burgers and fries. So this will be the probability of burger and fries. This line would be the probability of burgers and chips. And really, it's the conditional probability of the, you could look at it this way, the probability of fries given burgers. Because we gave them burgers and then we've got fries. Okay, so let's take a look and let's go ahead and do our multiplication along. We have 0.6 times 0.7 will be 0.42. 0.6 times 0.3 will be 0.18. 0.4 times 0.45 is 0.18. And 0.4 times 0.55 is 0.22. Okay, even if you don't necessarily need all of these probabilities, you should still do them because you want to add them all up and make sure that this total equals 1, just to check your work to make sure that you haven't made an error, and it doesn't really take a whole lot longer. So that's AP tip number 2. So we went ahead and showed all of our probabilities here, even though we're probably not going to need them all because it helps us check our work. It's a good idea to hold on to. So the other option we could have done is we could have made a two-way table. So just depends kind of on how your mind works. So in our table here, we had fries and chips, and we had burgers, and we had sandwiches. Now, based off the story problem, it said the probability of a burger was 0.6. So that's going to be 0.6. The total here will be 1 for 100%. That means the probability of a sandwich is 0.4. Okay, now when we look, we have burgers and fries, which we did right along here, for 0.42. So burgers and fries. So if this is 0.42 and this is 0.6, that means burgers and chips is 0.18. All right, then we had fries and sandwiches. So the probability of a sandwich and fries was 0.18, which makes this last section 0.22, so we can add up to the 0.4. And when I add down, I get 0.6 and 0.4 for our total. So either one of these can help us answer the questions. So let's kind of take a look. I'm more of a fan of the tree diagram. It makes a little bit more sense to me, but take what works. So what's the probability of sandwich and fries? So I follow and I say the probability of a sandwich and fries was 0.18. Probability of sandwich and fries equals 0.18. In the two-way table, fries and sandwich, there's your 0.18 right there. What's the probability of fries? So in the two-way table, this is pretty easy to see. The probability of fries is 0.6. If we're looking at the tree diagram, we would want here, I have fries here or here. So that means we would need to add these two up. 0.42 plus 0.18 is 0.6. So you get the same information. So what is the probability of a sandwich given they order fries? So the probability of a sandwich given that they order fries. So given that they order fries means 0.6. So that's out of these 0.6, what's the probability they order a sandwich? 0.18. When I divide that down, that gives me a 0.3. Going about this from the two-way table is given that they order fries, so that's our 0.6 from here. Of these 0.6 people, what ones ordered a sandwich? That'd be the 0.18. and still it divides down to the 0.3. Now, we use these two to help us, and that's going to lead us to the third AP tip for today. Your formulas on the formula sheet should really be your last resort for probability problems. You want to try to use your model instead. You guys do very well with kind of understanding where numbers come from and how to use the models, much better than we do the formulas. The formulas can be a little bit confusing. So hopefully that was helpful for you. Let me know if you have any questions, and I'll see you in class.